Our planet is a blue planet. From a distance, it is the oceans that define it. This great expanse of water covers most of the Earth's surface. We are creatures of the land. We tend to think of the ocean in terms of its surface. We see the waves, the tides, and the coastlines. But this is just the very beginning of the story. Beneath that shimmering sunlit surface lies a world of profound depth, a world far larger and more mysterious than the one we know. It is a realm of crushing pressure, eternal darkness, and freezing cold. And yet, against all odds, it is a world that is filled with life. Today, we will embark on a journey. It will be a slow and steady descent from the familiar world of light and air, down to the very deepest point on Earth. We begin our journey at the ocean's surface. This is the boundary between two worlds, the world of air, the world of water. It is a place of constant motion. Waves, driven by the wind, travel for thousands of miles across its face. Tides, pulled by the moon and pulled by the sun, cause the sea level to rise and fall with a steady, reliable rhythm. This is the part of the ocean we know best. The sun shines brightly here, warming the upper layers, giving the water a familiar blue or green hue. To put this into a human perspective, think of a swimming pool. A typical backyard pool is about 1.5 meters deep, a large public pool, perhaps 2 or 3. We can stand in these depths. We can see the bottom clearly. But beneath a small fishing boat, the water may already be tens of meters deep. This familiar surface is merely the thinnest of skins on a very deep body of water. We now enter the epipelagic, the sunlight zone, extending to about 200 meters. Here, sunlight fuels life. Reefs, shimmering schools, turtles, and giants that come up to breathe. Imagine a 50 or 60-story building, about 200 meters, submerged from base to top. That is the sunlight zone. We pass the 200-meter mark and leave the sunlight zone. This is the mesopelagic, the twilight zone, from about 200 to 1,000 meters. Sunlight is ghostly here. Reds and yellows vanish. The world turns increasingly blue. Temperatures fall below the mixed surface layer. Pressure rises fast. Bright colors give way to gray, black, and silver. Animals adapt, enormous light-sensitive eyes, or they make light of their own. Bioluminescence is common. Lanternfish, squid, jellyfish. Light to lure prey, to communicate, even to startle predators. At dusk, countless millions rise to feed. At dawn, they descend to hide, the largest daily migration on Earth. At the 1,000-meter mark, the last faint sunlight disappears. We enter the bathypelagic, the midnight zone, from 1,000 to 4,000 meters. No sunlight at all. The only light is the cold, brief glow of life. At 4,000 meters, pressure is roughly 400 times that at the surface. Water is near freezing, stable and seasonless. With no plants, life depends on what drifts down. A slow rain called marine snow. Creatures like the anglerfish have evolved ingenious strategies, luring scarce prey in the dark. To picture 4,000 meters, think of Mount Fuji. Its summit would not reach the top of the midnight zone. We are deeper than most mountains are tall, surrounded by blackness, cold, and almost unimaginable pressure, yet life endures. Our descent continues below 4,000 meters into the abyssal zone. This layer extends from 4 to 6,000 meters. Vast sediment-covered plains, among the flattest landscapes on Earth, stretch for miles. They are built from marine snow and microscopic shells that have settled for millennia. Occasionally, seamounts rise like islands from a sea of mud. Life is sparse but persistent. Sea cucumbers, brittle stars, tripod fish waiting patiently for food. At oases like hydrothermal vents, superheated mineral-rich fluids fuel entire communities by chemosynthesis. Bacteria harvest chemical energy, supporting tube worms, blind crabs, clams and mussels in extreme conditions. We have now descended to 6,000 meters. The Dal zone begins. Found only in deep oceanic trenches formed by subduction, these are the deepest, darkest, highest pressure places on Earth. Place Mount Everest here and its peak would still not reach the surface. Pressures can exceed 1,000 times surface pressure, like a heavy truck on your thumbnail, in water just above freezing. Trenches funnel marine snow and debris down their steep sides, making them surprisingly nutrient-rich. Isolated like sunken valleys, each trench can host unique communities, not a dead end, but a thriving ecosystem adapted to an alien world. We descend into the Mariana Trench, a crescent scar in the western Pacific. Within it lies the Challenger Deep, approximately 11,000 meters, nearly 7 miles down. Even Mount Everest, set upon the bottom, would have its peak buried under more than 2,000 meters of water. Reaching this point is a monumental engineering feat. In 1960, the bathyscaphe Trieste touched down with Jacques Piccard and Don Walsh. In 2012, James Cameron followed in a solo dive. Today, robotic landers and ROVs are our primary explorers. The bottom is not barren, a pale diatomaceous ooze. And there is life. Hadal snailfish, the deepest living fish, with soft, gelatinous bodies and molecules that protect their proteins. Giant amphipods swarm like swift scavengers. Foraminifera build intricate shells. Unseen bacteria and archaea process the drifting organic rain. A sunken log, a whale fall, ship debris, rare feasts that can fuel life for years. These organisms reveal life's limits, how proteins function, how nerves signal, how shells form under crushing pressure. The deep ocean connects our world. Slow currents move heat and nutrients, shaping climate. It absorbs vast heat and carbon dioxide, buffering us, but warming and acidification reach even the trenches. Stand by the sea and remember the vertical miles beneath your feet. From flashing twilight to the midnight zone, from abyssal plains to the Hadal trenches, a world of depth and complexity.